Hello everyone and welcome back to part 3 of the 7.7 and 7.8 video lectures, which is going to be properties of real numbers and some more advanced simplifying of algebraic expressions. So the first property of real numbers that we're going to cover is called the distributive property. And the distributive property involves when you have a constant that is, or really whatever, constant variable, really anything that is being multiplied by parentheses. And inside those parentheses, you have either addition or subtraction. So A, B, and C, they can be numbers, they can be variables, whatever. If you have A times B plus C, that is going to be the same as A times B plus A times C. What you do with distributive property is if you have a number or variable that is being multiplied by parentheses, you take what is being multiplied and you distribute it to everything in the parentheses. And when you distribute, you multiply. So if you distribute this A, you will multiply A times B, and then you will add to that A times C. And it really doesn't matter if the multiplication comes before the parentheses or after the parentheses, because as we're going to talk about more in this video, order does not matter with multiplication. So if you had B plus C times A, it is going to be the same idea. You would take this A and you would distribute it to both the B and the C. So what we're going to do is we are going to simplify each of these expressions using the distributive property. Now you might remember that we covered in the last video, when you multiply a variable by a constant, what you do is you multiply the numbers and you leave that variable alone. So for this 2 times parentheses x plus y, remember the multiplication is implied here, so there is implied multiplication between the 2 and the parentheses. There is technically a 1 in front of this x, and there's technically a 1 in front of this y. So when you distribute the 2, we're going to take 2 and we are going to multiply it to every single term in the parentheses that's attached to it. And then to do that, we're going to multiply the numbers, and then we're going to leave the variables alone. So 2 times 1x, 2 times 1 is 2, and we're going to leave the x alone. Then we're going to distribute the 2 to the y, so 2 times 1y, so 2 times 1 is positive 2, and we're going to leave the y alone. And then you would see if you can simplify this any further. X and y are unlike terms, so this is going to be your final answer. Remember, when you are asked to simplify, you are asked to do any properties that you see, and if you have like terms, to combine like terms. So that's going to be the same thing for negative 5 times 3x plus 7. There is implied multiplication between the negative 5 and the parentheses. So let's take a look in the parentheses first. Inside the parentheses, we have a 3x and a plus 7. Are these two terms like terms? They are not. So in the parentheses, we have unlike terms, so there's nothing to do in the parentheses. We can't combine 3x and 7, so there's nothing to do in the parentheses. So what we are going to do is we are going to distribute this negative 5 to everything in the parentheses. And since a number takes the sign to its left, this 5 is negative, so the negative is going to go with the 5. And I am going to distribute this negative 5 to every single term in the parentheses. And when you distribute, you're going to multiply. So I'm going to start with negative 5 times 3x. Negative 5 times positive 3 is negative 15, and you're going to leave the x alone. Then I'm going to multiply negative 5 times positive 7, because remember, this 7 takes the sign to its left, so that 7 is technically positive. So negative 5 times positive 7 is negative 35, which I've indicated with that minus sign. And then if you take a look, negative 15x and minus 35, these are unlike terms since one of them has a variable and the other doesn't. So this is fully simplified, and this would be your final answer. Now taking a look at this next one over here on the bottom left, we have negative times parentheses a minus 2b. So first of all, in the parentheses, a and minus 2b are unlike terms, so the parentheses are fully simplified. There's nothing to do inside the parentheses. but the parentheses are technically being multiplied by something. If you see a negative here just kind of hanging out in front of parentheses, there is an implied -1 that is being multiplied. So these parentheses are being multiplied technically by -1. And when your parentheses are being multiplied by something, you can take that something and distribute it to everything in the parentheses. So that's what I'm going to do here. Since these parentheses are being multiplied by -1, I'm going to distribute -1 to everything in the parenthesis. Keeping in mind there is technically a 1 in front of this A. So -1 times +1a is going to give us -1a. Then I'm going to distribute -1 to this -2b. Remember, number takes the sign to its left, so this is technically a -2b. So -1 times -2 is +2, and I'm going to leave the b alone. And then just really quick, you technically don't need that 1 in front of the a, so this -1a, I'm just going to simplify to -a plus 2b. And because a and b are different variables, these are unlike terms, so this is now fully simplified. So that's going to be the case anytime that you see parentheses that are being multiplied by something. So I see this parentheses x minus 5. There's nothing to do inside the parentheses since x and -5 are unlike terms, but the parentheses are being multiplied by +6. So since the parentheses are being multiplied by 6, I'm going to take this 6 and I'm going to distribute it to every single term in the parentheses. Remember, when you distribute, you multiply, and there's technically a 1 in front of this x. So 6 times 1x is going to be 6x. And then you're going to distribute 6 to the next term, and this is technically a -5. So +6 times -5 is going to give you -30. And since 6x and 30 are unlike terms, this is going to be your final answer. So that's going to be the case for each of these. So a lot of these are going to look pretty much exactly like the ones on the previous slide. So I want you guys to pause the video, distribute to simplify each of these, and then when you're done, resume the video so that you can check your answer. All right, so we have 3 times 2x plus 7. Now inside the parentheses, 2x plus 7 are unlike terms, so there's nothing to do in the parentheses, but since the parentheses are being multiplied by this 3, we're going to distribute the 3 to everything in the parenthesis. And remember, when you distribute, you multiply. So 3 times 2x is going to give us 6x, and then 3 times +7 will be +21. And since 6x and 21 are unlike terms, that is going to be our final answer. So then for the next one, we have -5 times 4x plus 6. In the parentheses, there's no simplifying to do since 4x and 6 are unlike terms. But we're going to take this -5 and we're going to distribute it to everything in the parentheses that it's being multiplied to. So -5 times 4x will be -20x. And then -5 times +6 is going to give us -30. And since these are unlike terms, that is going to be our final answer. So for this next one over here on the bottom left, if you see a negative just hanging out in front of parentheses like this, that means there is a -1 that is being multiplied to the parentheses. So these parentheses are being multiplied by -1, so we're going to distribute -1 to everything in the parentheses. So -1 times 2x is going to give us -2x. And remember, a number always takes the sign to its left, so this 4 is technically negative. So -1 times -4 will be +4. And since -2x and +4 are unlike terms, this is our final answer. So then for this last one, 4 plus 2x, these are unlike terms, so there's nothing to do inside the parentheses. But since the parentheses are being multiplied by 7, we're going to take 7 and we're going to distribute it to everything in the parentheses. So 7 times 4 is going to give us 28. And then 7 times positive 2x is going to be positive 14x. And since these are unlike terms, that is now fully simplified. Now for this next group, they're going to be a little bit trickier. So we have this parentheses 2x minus 6, and then remember there is implied multiplication right there. We're multiplying it by 2. So first of all, there's nothing to do in the parentheses since 2x minus 6 are unlike terms. But remember, order does not matter with multiplication, and that applies to the distributive property as well. So it really doesn't matter if this 2 is over here on the right, and it doesn't matter if the 2 comes after the parentheses or before the parentheses. This 2 is still being multiplied to the parentheses. So this 2 is still being distributed to everything in the parentheses that it's attached to. So I am going to distribute this 2 to every single term in the parentheses. So 2 times 2x will give us 4x. This 6 is technically negative, so 2 times negative 6 will give us negative 12. And then those are unlike terms, so that is fully simplified. So then for this next one, in the parentheses, we have 5a and 7b. These are unlike terms, so we can't combine them. But the parentheses are being multiplied by negative 3, so I'm going to take both the negative and the 3, and I'm going to distribute it to everything in the parentheses using multiplication. So negative 3 times positive 5 is going to give us negative 15a. And then negative 3 times positive 7 is going to give us negative 21, and then we're going to leave the b alone. And then again, a and b are unlike terms, so that is now fully simplified. Now, you can distribute even if inside the parentheses there are more than 2 terms. So for this next one, in the parentheses, we have x squared minus x minus 5. And these are all unlike terms, so we can't actually simplify this anymore. And the parentheses are being multiplied by negative 3. So even though the parentheses has 3 terms instead of 2, distributive property still applies. We are going to distribute negative 3 to every single term in the parentheses, all 3 of them. You can actually distribute to as many terms as you want. As many terms as there are in the parentheses, you're going to distribute. The only thing to keep in mind is that in front of this x squared, there is a 1 here, and between this minus and this x, there is a 1. And remember that a number always takes the sign to its left. So this is technically a negative 1x, and this is technically a negative 5. So here we go. I'm going to distribute the negative 3 to everything in the parentheses. So negative 3 times 1x squared is going to give us negative 3x squared. And then negative 3 times negative 1x is going to give us positive 3x. And then negative 3 times negative 5 is going to give us positive 15. And x squared, 3x, 15, these are all unlike terms, so this is as simplified as it's going to get. And that is going to be your final answer. Now, remember that order of operations that we covered a couple videos ago? Remember that parentheses or grouping symbols always comes first? So when you're simplifying any sort of variable expression, since the distributive property always involves parentheses, it should be done relatively first. The reason I say relatively first is because anything that is inside parentheses should always be done first. So that if you can simplify the expression inside the parentheses by combining like terms, you should really do this first before distributing. You're just going to save yourself some headache later. So that didn't really apply with any of these last few problems because in the parentheses there were like terms. But if in the parentheses you did have like terms, you would combine those first. Then, after the parentheses are fully simplified, then if the parentheses are being multiplied by something, you're going to distribute it before doing anything else. So after you distribute, then you should start combining like terms. So that's going to be the case here. Because parentheses always come first in order of operations, you should always distribute first before doing really anything else. So for this first expression, I have 1/2 x plus 6 and 1/2 times parentheses x plus 6 minus 4. I see parentheses. So I'm going to look inside the parentheses for a second. I have x and I have 6. Unfortunately, these are unlike terms, so there's no simplifying to do inside the parentheses. So since there's no simplifying to do inside parentheses, I need to distribute, because since distributing always involves parentheses, that should always be taken care of first, since parentheses always goes first in order of operations. And as you notice, I'm going to go back a couple slides. For each of these, every single time we distribute, notice the parentheses disappeared. Distributing is how you clear parentheses. So I'm going to clear these parentheses by distributing. Now, what do you distribute? You distribute what is being multiplied by the parentheses. So this 4 over here is being subtracted. We're not going to distribute that. Distributing is what's being multiplied. So what is being multiplied by these parentheses? The parentheses are being multiplied by 1/2. So since the 1/2 is being multiplied, that's what we're going to distribute. And I'm just going to leave this -4 alone for right now. Remember, there is a 1 in front of this x. So I'm going to distribute 1/2 to everything in the parentheses. So 1/2 times 1x, 1/2 times 1 is 1/2 x. And then 1/2 times 6, half of 6 is +3. So after you distribute, that clears out the parentheses. Then once the parentheses are cleared out, then you're going to combine like terms. So unfortunately, there are no other x terms, so nothing combines with this 1/2 x, so that'll be part of your final answer. But this +3 and this -4, they are both numbers with no variables. Numbers with no variables are considered like terms, so we're going to combine them. 3 minus 4 is -1. And all we have left over are unlike terms, since 1/2 x and -1 are unlike terms, so then that is going to be fully simplified. So we're going to do the same thing for this next one over here on the top right. I have negative times parentheses 4y minus 6. So as soon as you see parentheses, you should look inside the parentheses. I have a 4y and a -6. Unfortunately, inside the parentheses, these are unlike terms, so there's no simplifying to do inside the parentheses. But the parentheses are being multiplied by a -1. So I'm going to clear the parentheses by distributing -1 to every single term in the parentheses. So -1 times 4y is going to give us -4y. And then yes, the 6 is technically negative, so -1 times -6 is +6. And since these are unlike terms, this is going to be fully simplified, and that is going to be our final answer. So then for this last one, again, in order of operations, if you see parentheses, you have to take care of them first. So anything that is not involved in the parentheses needs to wait until you're done with the parentheses. So inside the parentheses, I have this 1x and this +4. Which unfortunately, these are unlike terms, but the parentheses are being multiplied by something. The parentheses are being multiplied by -1. So I need to take care of the parentheses first before I do anything else. So this 2x minus 3 that has nothing to do with the parentheses, just leave them alone. We will take care of them later. So to clear out the parentheses, I'm going to distribute the -1 to every single term inside the parentheses. So -1 times 1x is -1x. And then -1 times +4 is -4. Now that the parentheses are cleared out, now you can combine like terms, and now you can include the 2x minus 3. So let's take a look at the x terms. I have +2x and -1x. These are like terms, so I am going to combine them by adding the numbers in front. So 2 minus 1 is 1x. Technically, you don't need the 1 in front, so 1x is just x. Then any numbers with no variable are considered like terms. So the constants -3 and -4 are like terms. So -3 plus -4 is going to be -7. So then x minus 7 is your final answer. So that is going to be the case here too. The moment that you see parentheses, you need to focus on those first and fully simplify everything involving the parentheses before you even look at anything that doesn't involve the parentheses. So inside the parentheses, I have 3a plus 4. These are unlike terms, so there's no simplifying to do inside the parentheses. So then the next thing you look for is, okay, what are the parentheses being multiplied by? These parentheses are being multiplied by -2. So since the parentheses are being multiplied by -2, I'm going to distribute the -2 to everything in the parentheses. And remember, once the parentheses stop, distributing also stops. And then anything that wasn't involved with the distributing or the parentheses, such as this 14a minus 9, you're going to leave alone. So I'm just going to leave that 14 minus a alone, and I will take care of it later. And then also remember that when you distribute, you clear out the parentheses. So -2 times 3a is going to give us -6a. And then -2 times +4 will give us -8. Now that the parentheses are cleared out, now you can start looking at this problem as a whole, and now you can look at all of it and then combine any like terms. So I see this 14a and this -6a. Remember, a number takes the sign to its left. So since these are like terms, I am going to combine them. 14a minus 6a is going to give us 8a. Then the constants with no variable are also like terms. So I've got this -9 right here and this -8. So -9 plus -8 is going to give us -17. And since these are unlike terms, then this is going to be our final answer. Now, you also might remember that in the order of operations video, even within grouping symbols such as parentheses or brackets, order of operations does still apply. So when you read this problem from left to right, the first thing that you run across are brackets. So we're going to take care of the brackets first, which means everything that's outside the brackets, like I'm looking at this 2x minus 3, you're just going to leave them alone and you're going to tackle them later. Now, even inside the brackets, you do still need to follow order of operations. So if you look inside the brackets, I do see parentheses. So these inner parentheses do need to be taken care of being taken care of first, even before anything else inside the brackets. So I'm just going to leave the brackets alone, and I'm going to focus on those parentheses. Now, inside the parentheses, I have this x plus 7. Those are unlike terms, so there's nothing to do inside the parentheses. However, are the parentheses being multiplied by something? They're being multiplied by -3. So what I'm going to do to clear out those parentheses is I'm going to distribute -3 to both of the terms inside the parentheses. And I'm only distributing the -3 to the parentheses because the -3 was being multiplied by the parentheses. So when the parentheses stop, distributing also stops. Also, anything that did not have to do with those parentheses or the distributing, like that 2x, needs to be left alone and left exactly where it is. And when we distribute this -3, we are going to clear out the parentheses. So -3 times 1x is going to give us -3x. And then -3 times +7 is going to give us -21. Then, after that, that just cleared out the parentheses. However, I still see brackets, and remember brackets, parentheses, they're basically the same thing. So I still have a grouping symbol. Now, inside the brackets, do we have like terms? And you're actually going to notice that we do have like terms inside the brackets. So we're going to combine those first before we even do any distributing. So 2x plus -3x is going to give us -1x. Then, after that has been combined, now that the only things inside the brackets are unlike terms, now we get to look at, okay, what are the brackets now being multiplied by? The brackets are being multiplied by -3. So what I'm going to do is I'm going to take -3 and I'm going to distribute it to everything inside the brackets. Once the brackets stop, distributing stops, and when I distribute, that will clear out the brackets. Now this 2x, again, has nothing to do with the brackets or the distributing, so I'm just going to leave it alone, and I'm going to leave it where it is. And I'm going to take this negative 3 and I am going to distribute it to everything in the brackets. So negative 3 times negative 1x is positive 3x. And then negative 3 times negative 21. First of all, a negative times a negative is a positive. 3 times 21 is 63. Now that the brackets are cleared out, now you get to look at this overall problem and say, okay, do I have any like terms I can combine? And yes, we do. This 2x plus 3x right here is going to give us 5x. There was nothing to combine with that 63 since there were no other constants with no variable. And now that we are left with only unlike terms, this is our final answer. So 5x plus 63 is now going to be our final answer. So a couple other properties of real numbers. Distributive property was a property of real numbers, but there's a whole bunch of other ones. And some of these we've already used, and some of these you have known for a very long time. You just may not have had a name associated with them. Like, remember that property that we keep using, that order doesn't matter with addition? That's technically a property. That's technically called the commutative property of addition. And what it basically says is that you can switch the order of addition without changing anything, and order doesn't matter with addition. So A plus B is the same as B plus A. Now, associative property of addition basically says that if you have just one big long string of addition, you can group the addition however you want. So you can really add in any order or grouping that you want. So if you have three numbers A, B, and C, and you're adding them all together, you can either add A and B first and then add C, or you could add B and C first and then add A. So parentheses A plus B plus C is the same as A plus parentheses B plus C. So you can group addition however you want. Now, another operation where order doesn't matter is multiplication, and we've used the commutative property of multiplication already. Order doesn't matter with multiplication, so you can switch the order of multiplication without changing anything. So A times B is the exact same as B times A. And multiplication, you can also group multiplication however you want. So if you have one big long string of multiplication, you can group that together however you want, as long as all you have there is multiplication. As long as you don't have multiplication mixed in with addition and division, then order of operations kicks in. But if you have three numbers A, B, and C that are all being multiplied together, you can either multiply A times B first and then times C, or you can multiply B times C first and then multiply it by A. So that is called the associative property of multiplication. Basically says that you can group together a string of multiplication however you want. Now, a couple other properties of addition is the addition property of 0, which is a fancy way of saying that anything plus 0 is itself. So if you have some number or variable a plus 0, that is just going to be a. And since order doesn't matter with addition, 0 plus a is also equal to a. So it's just basically a fancy name for stating kind of the obvious. Now, remember several videos ago how we talked about how opposites always add up to 0? That's technically called the inverse property of addition, and it basically says that opposites, no matter what they are, always add up to 0. So a plus negative a is going to be equal to 0. And since order doesn't matter with addition, negative a plus a is also equal to 0. And this will apply for any real number a, including variables. Now, another property that you have been using for a very long time, we've already used in this class, is the multiplication property of 0. And this basically is a property that states that anything times 0 is 0. So for any real number or variable a times 0 is 0, and 0 times a is 0. So 0 times anything, including variables, is still 0. Now, another property that you have known for a very long time and had been using for a very long time is called the multiplicative identity property. And this is just a really fancy term for any number times 1 is itself. So for any real number or variable a times 1 is itself a, and 1 times a is a. The multiplicative identity property is basically why if you just see a variable with nothing in front of it, you can always assume that there is a 1 there. So that's just basically this property at work, and it's just basically a fancy way of saying that, hey, any number times 1 is itself, any variable times 1 is itself, which is technically why you don't need the 1 in front of this x, but you could put it there for things like distributive property or combining like terms. It might be helpful. Now, we've already seen this one in action. Multiplying a number by its reciprocal is always equal to 1. In the last video, you saw 3 halves times 2/3 x. It was something like this. And you might have noticed that when you multiplied 3 halves times 2/3, you got 1. And that is because 3 halves and 2/3 are reciprocals of each other. So multiplying a number by its reciprocal equals 1. So anytime that you multiply reciprocals together, no matter what order they're in, their product is going to be equal to 1. So for any non-zero number a times its reciprocal 1 over a is going to equal 1. And 1 over a times a is also going to equal 1. So 3 halves times 2/3 will equal 1. If you take 2 times 1/2, that is going to equal 1. If you take negative 1/3 times negative 3, that is going to equal to 1. So these reciprocals are also called multiplicative inverses. So multiplicative inverses is just another name for reciprocal, and when you multiply reciprocals together, you get 1. Now, division is actually the same as multiplying by the reciprocal. So if you take two numbers, a and b, and you divide them, so a divided by b, first of all, can be written in fractional form. So you can take a divided by b and write it as a over b. You can also rewrite a over b as a times 1 over b. So to divide, you can basically also multiply by the reciprocal of the divisor. This is why when we're dividing fractions, we can keep, change, flip, because dividing is the same as multiplying by the reciprocal. That's why keep, change, flip works when we're dividing fractions. Now, we've already covered this one a few videos ago. 0 divided by any non-zero number is equal to 0. We're not going to get into 0 over 0 in this class. That is nowhere near this class. Let's not even touch 0 over 0. But 0 divided by any not zero number is always equal to 0. Because remember, division is dividing something into equal parts. So if you have 0 divided by 3, for example, what you're asked is, okay, take 0 and split it into 3 equal parts. Well, if you have 0 cookies and you are splitting it among 3 people, then everybody gets nothing. So everyone would get 0 cookies. It sounds kind of stupid, but it does mathematically work. 0 split into 3 equal groups is equal to 0. So 0 divided by any non-zero number a is equal to 0. This also means that if in a fraction the numerator is equal to 0, that means the entire fraction is equal to 0. Now on the flip side, you cannot divide by 0. There are going to be several rules in math that are just pretty much unbreakable. This is the first one. One of the most unbreakable rules of math is that you cannot divide by 0. Division by 0 was what is called undefined or not defined. Means you can't even do it. It's not even going to be a real number. It just doesn't exist. You can't do it. So a divided by 0 or a over 0 is not defined. You can't even do it. It doesn't even equal a number. It doesn't equal anything. It just doesn't exist. So the reason why you cannot divide by 0 is because, remember, division is splitting into equal parts. So for example, if you have 3 divided by 0, this would basically be saying, okay, take 3 cookies and split them into 0 groups. How could you have 0 groups? The smallest you can have is 1 group. You can't take something and split it into 0 groups. So that is why that doesn't make any sense. And division by 0 is undefined. In terms of fractions, that means that you cannot have a 0 in the denominator. So a 0 in the numerator is perfectly okay, but a 0 in the denominator is not okay. So the number 1 unbreakable rule of math is that you cannot divide by 0. And remember, we're not even going to get into 0 divided by 0. But 0 in the denominator is undefined. So that is it for this video, and that actually wraps up all of the material from section 7.7 and 7.8. So that is actually going to also be it for the first exam, and that wraps up all of chapter 7. So in the next video, we are going to be starting in the next chapter, which is going to be solving our first equations. So thank you all very much for watching, and stay tuned for the next video. Bye-bye.